All right, problem 6.6 is a stepped shaft. We can do all of this geometry in one revolve. We do need to take a look at the drill point here because it looks to me like a 90 degree. It doesn't look flat enough to be 118 degrees. So if we use the hole wizard, we're going to have to adjust for that. But since it isn't called out, we'll see how close we get to this number. So we're in millimeters. Part origin is at the left center center lines, and revolves. And we can go ahead and get this one started. New part millimeter, front plane, based on the isometric. And we're going to go center line, horizontal, infinite length. All right, and the reason I like the infinite length again is that I will not run out no matter how much geometry I lay over top of this. It won't get away. So I don't really want to do those with the sketch numeric input, so I'm going to toggle that off. And that first diameter, well, it goes to the outside. So I'm just going to rough in the shape because everything's coming off of the right side. We'll want to stop wherever it makes sense that we can work on this geometry. So 7, and then I want it to be in diametral since that's what we're given for the dimensions. We go 20 and 26. So everything else should be pretty good there. Need to follow that extension line for that one all the way over, and that one's going to be 16. And notice that the arrow, the icon, is still in the D for diametral dimensions, so I should just be able to pick that and place the dimensions. So 16, and then when I hit escape, I'm going to be able to shift back into the linear dimensions. And I got the midpoint, which isn't that big of a deal. It's just when I want it to select the midpoints, then that's usually when it doesn't. So all right, so let's start working on the steps. So we're going to have a first step, and we're also going to have to watch out. We do want horizontal. I just don't want any like coincidences or, all right, so I slipped into click click, but I don't want any coincidences or collinears popping up. So let's see what I did. 1, 2, 3, 4, and 1, 2, 3, 4. Actually, there's another one in there, isn't there? All right, so let's add some dimensions so I can get this sorted out. All right, so we'll drop in a few more horizontals. So 28, and then we're going to go 42. Okay, so these are staying pretty close. And you just scroll up a little bit, 55, and then 72. So, yep, there was another one. And then we can come back to the center. All right, so normally I would go ahead and close this off, but I do want to show you what is going on when it is not closed off and it asks you if you want to allow SolidWorks to close off for that feature, so it can complete the revolve. It does need to be an enclosed region though. So we're going to go 8, and then we'll go up to 12, and then we'll go to 16. Is there another 16? Yep, that was the same as coming all the way across, so 16. And then the outer next one up was also 20. All right, so I could have made that one and that one collinear, but I think it's safer if I did mess something up or I missed something, then I'd be able to correct just those items. All right, so revolve boss base. The sketch is currently open. A non-thin revolve feature requires a closed sketch. Would you like to sketch the sketch to be automatically closed? Yes. So it's going to draw me a line from endpoint to endpoint, go into the 360-degree revolve, and if I edit that sketch again, then I will have an object line. So if you think about it, go ahead and put the object line to close it off. The only time it really gets into trouble where it generates self-intersecting, so maybe it tries to go from that corner and clips across the edge or does something weird with the revolve. All right, so I'm going to go ahead and use the hole wizard, and that is upper middle, and we are in ANSI metric. We're going to choose a standard. Let's see, does it give me a tooltip? Just hole as its description. What it asked was I had previously changed numbers and made little adjustments, so it wanted the to know if I wanted to retain those or kick them out. So I let it kick it out. So 5 millimeters for the depth, and we're already showing the custom sizing. There's no adjustments. It is not through all. It is going to be a blind condition. And if we go to the tip versus the shoulder, we may end up, this is where that 118 versus 90 comes in as a drill point. Standard drill point is 118 degrees. There are different geometries. 135 is another common. 90, not so much, but it is there is tooling that is available to generate that. So if I go to the tooltip, let's go 38. I think that'll be easier to measure. So we'll go ahead and place a point on the origin, and because I'd already selected that face, it put the sketch directly on that face, and we'll go ahead and accept. So what I'm looking for is to be able to see that inside edge, and we're going to measure the shoulder to the outside face, and I'm not getting any numbers down here, so I'm going to go millimeter or to the measure and make sure that I'm in millimeters, and we actually end up with 36.5 because of the 118. All right, so if I just drew that as part of the revolve, I could have put the angle in there, but it's not called out is kind of the issue that I'm having with it. So we'll go back in, show the custom sizing. I can override it to 90 degrees and see if that pulls it back. And we'll go into the measure. Now I have 35.5 degrees, so it's actually somewhere in between. So since I drew it, I did not draw it into the geometry. I've created that little bit of a problem. It's an odd angle and not something that is really manufacturable. If it's not 90 and it's not 118, that creates a little bit of an issue. So let's suppress that because it is a good bit of geometry for the explanation. Also, I would like my corrective geometry to be before it. So if you go to, you see the little fingertips over the rollback bar, you can move that before and it treats it, even though that's suppressed, it treats it as it's going to automatically insert it before that feature. So going back into the front plane, we will open up the sketch. Don't know that that needs to be a center line. So keep in mind that you don't have to have the center line, but it requires an additional selection. Also, I'm not going to get the diametral dimension, so 2.5. And the bottom line is going to be the 38 to the tip, and the top line is going to be the 36. All right, so when we go in and tell it to do to the features and then go to our revolved cut, the axis of revolution is going to be that axis, that object line that we generated and I'll cut 360 degrees. And then we can roll back and see what the difference in the geometry is. All right, so our number is 21076. So evaluate mass properties 21076. So I would like to do the what if scenario. Let's go ahead and suppress the cut revolve, unsuppress the 5mm, and go into the mass properties. And now we're at 21082. So just a little bit of difference, but enough that it puts us off on the geometry. So I'm going to go into the section view and take a look. So that was 90 degrees. The 118 was even a little bit flatter. So if I reverse that process, unsuppress, suppress the 5mm, and it didn't create any major issues. But let's see if we can measure. Those aren't really edges, so I don't know if it'll let me. 102.68. So if you really want that to be 102.68 and you send this part to my machine shop and say that has to be whatever, then I'm going to charge you for grinding a custom tool to drill that hole and hold that tolerance. So choose wisely.